So this is task 2, the evacuation hub, located in Mesa, Colorado, and Caitlin and I worked on this one.
Okay, so this is our site-specific suitability analysis. And the first one is our erosion resilience map. And so the darkest color is going to be where there's the slightest amount of erosion, and then working outwards on the color, the lightest one is the most erosion. And so our site is on the slight erosion side. And then for the flood resilience map, the darkest color is flood zone X, which means it's not in a floodplain, which is really good. Since it's along the river and a little bit higher up in the mountains. The next one is road suitability map, and then our site falls within a moderately suitable, which works out because it has close proximity to a highway and allows for people to enter the site a little bit easier. And then lastly, we have structure suitability map. And again, our site falls in the moderately suitable range, so we could definitely build structures where we're going to do it. And then this is just a combined map of all of those subcategories, and it just, again, solidifies our choice on a site location.
This is our overall site plan. Some key features of the site plan come from our prototype toolkit. So starting off with renewable resources, we have solar panels on top of each housing pod, which are all of these, as well as wind turbines across the open space around the southern housing pods. Each of these outer pods, so these outer 6, are housing pods with a total of 6 of them. These pods are connected by green roof spaces, that also connect them to the central medical hub, being this pod right here. The exterior of each pod has vertical farming hubs, which is a little bit easier to see with some visuals that we have later. We also have water harvesting that happens on the bottom of each of these pods. In terms of transportation, we have a central transportation hub up here, aircraft landing on top of this hub, as well as emergency aircraft landing on top of the medical hub. And we also have elevated walkways connecting each of these pods, and then an autonomous train that goes around the entire site for easy transportation.
Okay, and then this is our phasing plan. So in the first phase, it would be 5 to 10 years, and we wanted to definitely have the most important stuff out there first. So the central transportation hub to like get people in, the wind turbine farm, because that's going to be how we practically run our site, so we don't have to do carbon emissions. We would put out 2 housing pods. We would have the medical hub, and then 1 green roof. And then for phase 2, we would add 2 more housing pods and 2 more green roofs. And then finally, phase 3, we would then add 2 more housing pods and then 3 more green roofs. And we would also add the autonomous train around the site just to kind of complete it and frame it off.
The co-benefits from each phase, so starting with phase 1, the housing would have a 200,000 person capacity, a green space of 120,000 square feet, and an elevated walkway of 72,570 square feet. Moving on to phase 2, the housing capacity would be 400,000 capacity, which is a 100% increase from phase 1. The green space would be a 360,000 square foot capacity, which is a 200% increase from phase 1. And then for the elevated walkways, it would be 138,000 and some change, I guess, which is a 91% increase from phase 1. For phase 3, housing would be a 600,000 capacity. That's a 50% increase. The green space would be 720,000 square feet, which is a 200% increase from phase 2. And then finally, the elevated walkway would be around 226,000 square feet, which is a 63% increase. This is our cross section through our medical and housing pods. So this right here is going to be our medical hub. And then this is one of our housing pods, one of the 6th. So the top is going to be energy conversion and storage, as well as hovercraft stations on the medical hub. You can kind of see some hovercrafts over there. Going down, that's going to be pedestrian circulation, the medical hub and different medical units kind of going down. And at the very bottom would be food and water storage, as well as water harvesting. You can kind of see a skywalk right here connecting these 2 pods, as well as these green roofs connecting over here. For the housing pod, the very top is going to be energy conversion and storage with solar panels on top. Again, that pedestrian circulation. Then the housing pod, entertainment and dining, because of course people are going to be here. And then below that, it's going to be that food and water storage once again. Here's a little bit better of a visual for the vertical farming spaces that you can see. They're kind of on the exterior of all of these hubs, and you can see it over here as well. The wind harvesting is going to be over here on your left, as well as this autonomous rail line kind of going around the entire site.
Okay, so this is our first performance evaluation, which is wind turbines. This is going to be the majority of our electricity coming from wind turbines. So basically, we would have about 40 on-site wind turbines, which would produce about 262,800,000 kilowatts annually, which is about enough to supply energy to all the housing pods. That's not talking about the medical, so just housing. And then it will reduce our carbon emissions by 128,000 tons annually. Wind turbines are pretty much carbon neutral, so that's where we're getting that number from. The next one would be solar panels on top of each of the housing pods. And so our on-site solar panels would produce about 9,636,000 kilowatts annually. And it will be a 99% decrease in carbon production consumption. That's like common with traditional electricity, such as like fossil fuels and gas and that kind of thing. And then again, it would just convert the sunlight into DC electricity, which is direct current, and then to AC, which is alternating current, which is what we use to power like all of our appliances within houses. And then lastly, our green roof. It would end up, after all the phasing, sequestering about 25,000 pounds of carbon annually with the plant uptake. And then we could also harvest about 26 million gallons of water with a runoff coefficient of like 60%. So we would get a lot of water from that as well.
So we have some perspectives of our space. This is our green roof garden. We really wanted to implement this to help just with like the mental health of the people who are coming to this space. We really wanted it to just be super abundant and have fruit trees and pollinator attractors. So this is just kind of an example of what it would look like on that space. Here's an example of our elevated walkways. They're glass so you can kind of see out and also be able to see into nature in all of our green roofs, as well as kind of just the exterior because it's in a really pretty space. Here's another perspective of our vertical farming hubs, since it's a little bit unorthodox. So this is kind of what it would look like. So it has glass in the exterior of the pods kind of containing it, but these large, tall vertical farming hubs.
Okay, so